So it's 4 to the 11. 4 to the 11. Because it's just like adding. It's just like 4 has an exponent of 1. So you add it to the 10. To the exponent of 10. Right.
Let us see. Alright, wherever you are, we're going to bring it back. A quick little turn to talk to your neighbor. 3, 2, 1, 0. Thank you. I saw 2 popular answers. Let me give you the first popular answer I saw. 4 to the 10. That? Nod your head if you see that. And then I saw this. So I picked 3 popular answers. And I saw this. Is there someone that wants to make an argument for any one of these? Someone that wants to make an argument for any one of these using some good logic? What do we think? Kimberly, what do you think? Snaps if you agree with that. Snaps if you disagree with that. Okay. Are you sure?
Yes.
Make an argument. That'll convince me.
Because 4 is 4 to the first power, and then you use the product property, and you add those, and you get 4 to the 11.
You sure? I know if someone had something else to say beyond that, or disagrees with that. Genesis?
I agree with her because I got the same answer for something because in product property, the base stays the same in
Okay. You sure?
Yeah.
Daishali?
I think it's the first one because if it's saying that amount quadruples, then it's like 4 times 4 times the 4 exponent.
What do we think about that? What do we think about that? She said the amount of quadruples, right? These are 4 times 4 times. What do you think?
I think it's the last one because the factors stay the same and aren't just supposed to add the exponent, so it's 4 to 11.
So we've got this, now we've got, so no one thinks it's this one? Al, you think it's this one? Yeah? No? Okay, so maybe I'll tell you that this is incorrect. And we're down to 2, and that's incorrect. So let's talk about this guy and that guy. We got Daishali thinking it's this. A few other people thinking it's that. Al, you want to make one last comment on this? Okay. Okay. What do you think, Daishali, about that logic? Are you convinced? No? Not yet, right? So you said, okay, this 4 to the 10th to the 4th power is 4 to the 40th. So let me take a totally much smaller number to deal with. If I say 2, yeah? And I want to quadruple 2. How would I quadruple 2? How would I quadruple 2? Okay, Adonis? Multiplied by 4. What is 2 times 4? 8. In your logic, we're doing 2. You wanted to take it to the 4th power, which is what we did over there. We took that, whatever the thing we had was, 4 to the 10th to the 4th power. When we are quadrupling it, are we actually taking it to the 4th power? Did I quadruple it here? Is this times 4? No. Okay? So, I love the thinking, Daishali, and I tried to trick everybody else, but this particular one is incorrect, right? Based on the reasoning of every other case except. So there were at least, 4 different explanations of why this is correct, right? So this is so interesting. From here to here, when I just move the exponent by 1, we quadrupled something, right? So let's take a look on the next page. Turn to the next page. All right? Now let's take a look at these quick brackets. Go ahead and try those on your own real quick. If you double 2 to the 13th, what will you get? If you triple 3 to the 20th, what will you get? You quadruple 4 to the 10th. What will you get? I gave you a very short amount of time for a very specific reason. Is there a lot of math you need to do here? No, right? If I double 2 to the 13th, I'm taking 2 to the 13th and multiplying it by what? 2, which will give me 2 to the 14th. Okay, check off your work. I'm doubling something, I'm just, right? Well, this is big. If I triple 3 to the 20th, I'm multiplying it by 3, so this is going to give me 3 to the 21st. And this one we just talked about, right? If I quadruple 4 to the 10th, times 4 to the first, 4 to the 11th. Okay. Now, Amelia asked a great question. Amelia, can you ask your question?
What if you wanna, like, for example, what if you wanna double a number but it doesn't have the 2 in it?
Okay. So let's, interesting. So let's talk about this. Let's take, let's do 3 to the 4th power. Okay? Let's do 3 to the 4th power, and let's say we want to double it. If we're going to double this thing, what are we going to multiply by? 2. Who has a thought on what you could do here? What would work here? What do you think? Think about it. Keep your hand up and let everyone else keep thinking. Double this. Hey, Mon, what do you think?
Multiply the base and the exponent by 2.
Okay, so you'll get what, 6 to the 8th? Yeah? Anyone, something to say about that? Al, what do you think? So you said multiply the base and keep the exponent, so you go 2 times 3, which would be 6 to the 4th power. Okay? Jeffrey?
Well, my answer would be 3 to the 4th power times 2 equals 6 to the 5th power. Because the 2 has an invisible 1 exponent.
Okay. Here's an invisible 1 exponent. Okay. That's true. This is I'm going to put that 1 here. That's what you're telling me, right?
Yeah, that's what I'm saying.
Okay. Anything else? Any other thoughts? Amelia, back to you who asked the original question. Yeah.
I was gonna say that like, if it's a small number, you just put the 3 out and 3 at a time, and then times the 2.
Say it much louder.
That if, like for example, for that one, you can put like 3 times 3 times 3 times 3 times 2.
Okay. So this one right here, right? This is 3 times 3 times 3 times 3 times 2. Yeah? What? I love that look on that face. What?
You can multiply the whole 3 times 3 times 3 times 3 by 2. So you put it in parentheses. And then that's going to be like 2 times 3.
Yep.
6 times 6 times 6 times 6.
Can I multiply this 2 by every one of these things? Let's think about this for a second. Let's actually use our math intuition here. Let's actually figure out what 3 times 3 times 3 times 3 is. Yeah? What is 3 times 3 times 3 times 3? Well, 3 times 3 is 9. Times 3 again is, times 3 again? 81. This whole thing right here is 81, right? This thing right here is 81. And this thing over here is 2. Well, 81 times 2 is what? So let's take a look. 3 times 3 times, that's what this is. Is that the same thing as 6 to the 8th power? This over here is what? 6 times 6 times 6 times 6 times 6 times 6 times 6, 2, 3, 4, 5,
No,
6.
that's wrong.
Why? Why is that wrong all the way? You don't have to do all that math. Why is that wrong all the way, William?
6,
Yeah. So this right here, right, is not equivalent to that. Nope. I can't do whatever that told me to do. All right. Let's maybe draw a line here and see. Let's think about this one. Would this be 6 to the 4th? Would that be 162? I don't know. What's 6 times 6 again? And what's this sum then? 36. 36 times 36, 162? Oh, goodness. We got one more. Who has something to say about this one? Who has something to say about this one? I see people shaking their head. Chris?
If 6 to the 4th is in 162, and if it has a higher exponent, it's not going to equal those.
That's a great point what he just said, right? I don't even care what this is. This is already going to be bigger than that. So this is not right either. Does anyone see why I can't do any of the things that I just did? Keep your hands up. I want to give some people a hint. Read this. What? Who has something to say? Let's say, look, keep your hands up, keep your hands up. Who has something to say now about what we're talking about here? Mika, what do you think?
If you're trying to multiply the numbers, they need to have the same base.
Multiply numbers with exponents, right? If you're going to use the properties of exponents, they have to have the same what? They have to have the same base. Al?
Can I say that as a different answer?
Yes.
If you multiply by 2, and like put 1 3 times 2 and it's 6, and you subtract that from the 4. I say that I am not.
Say that again. So let's see here. You said 3 to the 4th times 2. What do you want to do?
I just take 1 3 away from 2.
Hold on one second. You're going to say, I'm going to make this 3. You say, okay, let me take this one away over here. Yeah? Put it over here. Can we do that? Yeah, you can do that. Because you multiply these numbers in all different ways, right? 3 times 2 is what? 6. So you can say this is
3 to 3.
times 6. Are these equivalent? Yes, they are. 3 times 2 times 3 is the same as 3 times 2 times 3. 3 times 2, these are equivalent. Yes, but look, I couldn't mess around with the bases or the exponents. There wasn't a nice way to do it. There wasn't like add the exponents, subtract the exponents, multiply the exponents. Because they had a different what? Base. Because they had a different base. So these guys only apply when you have the same base. Okay? Which is why when I did this problem right here, I doubled something with a base of 2. I tripled something with a base of 3. I quadrupled something with a base of 4, right? That's why that worked really easily. But it doesn't work if I try to double 3 to the 20th. Then I just have to leave it 3 to the 20th times 2. So over here, the best answer you can have, if I double 3 to the 4th, I'm going to get 3 to the 4th times 2. That's really it. You just got to leave it like that, or you can simplify it by standardizing the entire thing. Yeah.